Welcome to Lasea class. I am your teacher, Jan Lasea. A blessed day to everyone. Today, we are going to learn Global Positioning System or GPS. Receiver. Global Positioning System or GPS is a satellite-based navigation system that provides geolocation and time information to GPS receivers on or near our planet Earth. Essentially, it allows you to determine your location, such as the latitude, longitude, and altitude, and track your movement. Latitude means it is the horizontal mapping lines on our planet Earth, while the longitude is the vertical mapping lines of our planet Earth, and the altitude is the height of your location as determined by the GPS system, measured from the above of the ellipsoid. Also, another GPS system can also calculate the height of your location measured above the sea level. Global Positioning System was developed by the U.S. Department of Defense. It was designed to assist soldiers and military vehicles, but it is available to anyone with a GPS receiver such as your smartphone. After some years, Global Positioning System is a common system that most of us use to reach from one location to another location. The GPS systems combine a network of satellites that constantly send coded information in the form of radio signals. After the receiver receives the signals and interprets the transmitted information from the satellites or GPS satellites to locate the position on Earth accurately. This satellite system is a congestive of 29 GPS satellites situated at almost 20,000 kilometers above the Earth's surface. The GPS satellites are located at 6 Earth-centered orbital planes and travel at a speed of 14,000 kilometers per hour. The GPS device will first establish a connection with at least 3 to 4 GPS satellites. After that, GPS satellite broadcasts a message including the location of the receiver. If the GPS receiver receives a group of messages from different GPS satellites, then it will calculate the exact position using and then process them, and it is called triangulation. GPS satellites need an unobstructed line of sight or clear line of sight for the broadcast. GPS relies on a network of satellites orbiting the Earth. These satellites transmit signals that GPS receivers on the ground can pick up. By calculating the time it takes for the signals to travel from multiple GPS satellites to the receiver can determine its precise location. Some usages of Global Positioning System are the following. 1. Location. With the help of GPS, we can find the exact position of the object. 2. Navigation. We can navigate from one location to another with the help of GPS. GPS technology is also useful for transportation management. 3. Tracking. With the help of GPS, we can monitor object movements like speed, distance, and position. Next is mapping. GPS also helps in creating maps of the world. And then finally, timing. GPS also provides the estimated time for reaching the destination. Measurement, it depends on the speed and the object movement. The materials we need to build a simple project are the following. We need to purchase this U-Blocks Neo 7M GPS module HW-539 GPS receiver. Next, we need to purchase this GPS SMA antenna for that GPS receiver so that we can be able to pick up lots of GPS satellites. We need also to purchase LCD 2004 I2C LCD 20x4 display. The microcontroller that I have used in this simple project is the Saling Uno, which is a enhanced version of Arduino Uno, and it is compatible. You can purchase the Saling Uno at the Layad Circuits Electronics Engineering Supplies and Services, located at room B314 Lopez Building, Session Road, Baguio City, Philippines. Or you can visit their Facebook from this URL address. We need also to have jumper wires, USB cable for Arduino Uno, smartphone charger that converts 220 AC to 5 volts, either 1 ampere or 2 amperes or even 2.1 amperes adapter. Also, we need to have this micro USB Type B cable. Next, we need to use the Arduino CC++ IDE. We need also to install Arduino libraries using the Arduino IDE. The following. One is the Liquid Crystal I2C by Frank de Brabander. And then secondly, the Tiny GPS++ by RES. These two libraries are needed for our code to be uploaded to the Arduino Uno microcontroller so that it will function very well. We need also to have a laptop or a desktop PC. This is the wiring diagram for the simple project. First, we focus our attention to the U-Blocks Neo 7M GPS receiver module. The BCC pin of the GPS receiver module is connected to the 3.3 volt pin of the Arduino Uno. The ground pin of the GPS receiver module is connected to the ground pin of the Arduino Uno. The TXD or transmit data pin of the GPS receiver module is connected to the digital pin number 3 of the Arduino Uno. The RXD or receiver data pin of the GPS receiver module is connected to the digital pin number 4 of the Arduino Uno. Next, we focus our attention to the LCD 2004 I2C LCD display. The ground pin of the LCD display is connected to the ground pin of the Arduino Uno. The BCC pin of the LCD display is connected to the 5 volts pin of the Arduino Uno. The SDA or synchronous data pin of the LCD display is connected to the analog pin A4. The SCL or synchronous clock pin of the LCD display is connected to the analog pin A5. We need also to make sure that our GPS receiver module, the transmit data pin, must be connected to the RX pin assigned from our code using the software serial library, which is the digital pin number 3. and then the RxD of the GPS receiver module pin or the received data pin must be connected to the assigned digital pin number 4, which is the TX pin of our software serial. Note that the transmit data pin must be connected to the receive pin, and then the receive data pin must be connected to the transmit data pin. If you accidentally connect the BCC of the GPS receiver module to 5 volts of the Arduino Uno, then there is a possibility that it will be damaged. And that is what happened to my GPS receiver module. I accidentally connected the BCC pin to the 5 volts of the Arduino Uno. Now, the BCC pin of the GPS receiver module does not function anymore, and it is damaged. However, you can still give power to the GPS receiver module by connecting the micro USB Type-B cable if the GPS receiver module cannot be powered by the BCC pin. Do not connect the BCC anymore to the Arduino Uno, but only the ground, the transmit data pin, the receive data pins must be connected to the Arduino Uno. Let us learn the program codes to be uploaded to Arduino Uno microcontroller. We tell to the Arduino C++ compiler that our codes need to use the following libraries, namely Liquid Crystal I2C, I2C, Tiny GPS Plus, and the built-in library software serial by including their file headers. I declared constant variables, namely the Rx pin assign a constant 3 and TX pin assign a constant 4. And then, if you look at this table, the GPS receiver module transmit data pin must be connected to the Rx pin assigned with a digital pin number 3. And the RxD or the receive data pin of the GPS receiver module will be connected to the TX pin assigned digital pin number 4. And then the GPS baud rate or GPS baud and assign a constant value of 9,600 bits per second. I declared a tiny GPS plus object named GPS. I instantiated a software serial object named SS and passed the constant Rx pin and TX pin as arguments. Next, I instantiated a liquid crystal I2C object named LCD, and I passed the LCD address of 0x27, 27 hexadecimal with 20 columns and 4 rows. The function setup is automatically invoked and run once at the start of program execution. The body of the function setup will initialize our LCD, and then it will open the backlight of our LCD display, and then it will clear the screen. Next, we set the serial communication to a baud rate of 115,200 bits per second so that we can display messages to our serial monitor in our laptop or desktop PC for debugging purposes. Next to that, we assign the software serial with a baud rate of 9,600 bits per second, and then we print some messages, both the serial monitor and then the LCD display. And we can see one string value displayed onto the serial monitor, and several strings are displayed onto the LCD display. And then it will wait for 10 seconds so that the viewer can read the output to the LCD screen for about 10 seconds. When the function setup is finished, executed by the microcontroller, next, the function loop is repeatedly invoked and run repeatedly by the microcontroller inside the body of the function loop. It will check if our GPS receiver module sent to the Arduino Uno microcontroller some characters or sentences. This while loop will going to check if there are bits of characters sent by the GPS receiver to the Arduino Uno. And if there is, which is greater than 0, therefore, our GPS object will going to encode it. And then if it is a valid, it will now display information such as the latitude, longitude, altitude, the date, and then the time repeatedly. The code definition of the function display info will be shown onto the next slide. However, if our GPS receiver module did not send any characters or bits, and then this if condition is true, therefore it will display a error message in our serial monitor such as no GPS detected, check wiring. And if that is the case, this error, it will indicate that either there is no power to the GPS receiver or wrong connection connected to the transmit data pin and then the receive data pin of the GPS receiver module to the Arduino Uno. You need to check those things. Whenever the Arduino Uno receives characters of data from the GPS receiver module, then the function display info is invoked. The body definition of the display info will tell us that it will first clear our LCD screen and then it will print now information on both to the laptop or desktop PC serial monitor and then the LCD display the following. If the GPS module had a strong pickup or signals from the GPS satellites, at least 3 or 4 GPS satellites, therefore, it will indicate that the location is valid and it will display the location either in latitude or longitude. And as well as it will also display here in the LCD screen if there is a valid location that was computed, measured by at least 3 or 4 GPS satellites. However, if there is no GPS satellites detected, or if it is less than 3 GPS satellites, therefore, it will display invalid. And then there are asterisks that it will be printed to the value of the latitude and then the longitude. These are the codes which are the continuation of the body definition of the function display info. Next, it will display how many satellites detected by our GPS SMA antenna connected to our GPS receiver module. If there is a valid satellite, therefore it will display here in the LCD screen the number of satellites detected by our GPS receiver module, and at the same time it will also display in our serial monitor the number of satellites. Also, it will also display the date if there is a valid date. However, in the LCD display, I did not program to display the date because it lacks space. However, in the serial monitor, it will display the date here in the serial monitor. The month, the day, and then the year. Next, these are the codes which are the continuation of the body definition of the function display. The following code will display the measured approximate time, the GPS time. And if there is a valid GPS time, it will display the hour, the minute, the second, and then the centisecond. However, there is no display to the LCD screen, but we can only see the display result here in the serial monitor. The GPS receiver module with SMA antenna can receive signals from the GPS satellites when it is a clear blue sky. Also, when GPS satellites pass near through your place. There is no signal from the GPS satellites if it is a cloudy sky. Ladies and gentlemen, let us run and test. That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.